Okay, so this is the second video for the stat packet. Remember um, that you need to get that completed and understand what's going on. So here's the thing that we've talked about so far. So you've got the population mean and the population proportion, which is the entire population. But those aren't always known because it's just you can't collect everything. So we select random samples and we use random samples. But the issue that you have if you use a random sample is it's not exact. So there's a margin of error. And the margin of error is a number that describes how close we believe our estimate is to the unknown parameter. So like how close are we? Okay, so we study and we figure out what is the margin of error. So we calculate it depending on the parameters we're estimating. So for population proportion, our margin of error formula would be 2 times the probability, or sorry, 2 times the square root of the probability times 1 minus the probability over the sample size. Now, let me tell you, in a state test, they're probably going to give you these formulas. On the practice problems, they gave us this one. So I wouldn't worry about memorizing these too much, okay? All right, but where we find our confidence interval, which is how confident we are in something, is that whatever the sample is plus or minus the margin of error. So for instance, if we said something, there was a 34% chance of something plus or minus 3%, then 34 minus or plus 3 is 37%. And minus 3 is 31%. So we would feel like if we're somewhere in there, okay, somewhere between there, we feel like 31 to 37% of the students would feel this way. We'd feel confident in that, okay? So we're going to work through a few of those. So let's say we're trying to estimate the true proportion of students who think that school start time should start later. So we interview 250, okay, and 200 of them agree we should start later, okay? So our sample proportion is 200 over 250, or let's make it into a decimal, 0.8 or 80%. Okay, so we have to find our margin of error. Now look at your formula for that. Population proportion, we do 2 times the square root of the probability, which is 0.8. We're going to leave that as 0.8 times 1 minus 0.8, which actually will be 0.2, over, now be careful, the sample size, which is the 250. When we get this, this will give us our margin of error, and we would put it in the calculator. So 2 times the square root of 0.8 times 0.2 divided by 250. So I get 0.05 approximately. We're going to call that 0.05. Okay? So what we're saying is our confidence interval would be 0.8 or 80% plus or minus 0.05. So 80%, but 5% above that or below that. So if you go 5% below, if you want to think of it in percentages, 80% plus or minus 5%. That may be an easier way for you to think about it. Either way works. Well, 5% below 80 is 75%. 5% above is 85%. So we feel like we're confident that 75 to 85% of our students would think start time should be later. Okay. Now I left my old county, sorry. Okay. Using a mean. So we want to figure out the GPA, the mean GPA of all the students in Wake County. Okay. We don't ask them all. So we take a random sample of 150 students and find the mean GPA to be 2.85. Okay. So 2.85 is the middle. Okay, the margin of error for mean, go back up here, 2 times the standard deviation, which is 0.84, it tells you, over the square root of how many of your population, right? Or I'm sorry, of your sample size. And the sample size was 150. So I type this into the calculator. So 2 times 0.84 divided by the square root of 150. And I get 0.13. So that's my margin of error, 0.137. Now this is not a percentage. What we're saying is the GPA of people is 2.85, plus or minus 0.137. So we're saying that people could be 0.137 below 2.85. So we do 2.85 minus 0.137. So 2.713 and 0.137 above. So 2.85 plus 0.137. I get 2.987. We feel like we can expect students, okay, enrolled in Math 3 to be somewhere between these GPAs. Okay, so let's just do a few more of these. All right, do this one with you, and then I'm going to pause it and then give you a minute, and then you can fill out the worksheet and see if you can do these. So what is the margin of error for the survey? Okay, so it's margin of error. All right, so we've got 14%. So what you have to ask yourself if you come back up here, is it a population proportion or a mean? Okay, so how do we know that? So in a survey, 14% say they watch television more than 12. Okay, well this is a population proportion, or it's a proportion. Okay, and you can kind of get it from there. So we're going to do the margin of error. Okay, for proportion, if we come back up here, is 2 times the probability. So 2 times, oh, sorry, the square root of the probability, which is 0.14 times 1 minus 0.14, all over our survey, our number of people surveyed. So there you go. So we're going to put that in the, so 2 times the square root of 0.14 divided by 750. We get 0.025. Okay? Or that's really 2.5%. Okay, so our confidence interval, we know 14% said they watch it from our survey, but we're going to add and subtract 2.5% to find what that gives us. So 14 minus 2.5% would be 11.5%. 2.5 added to that would be 16.5%. So this, we're confident, reasonably confident, that 11.5 to 16.5%, somewhere in there, they watch more than 12 hours of TV per week. Okay? All right? So if you look at letter C, this team said 18% watch it. From your interval, do you feel confident? Well, we'd say we think it's probably not right, because we said the highest, or our high end, is 16.5%. Okay? All right. So what I'm going to do is I'm going to fill out these last the last three, and then I'll pause it, post them. You can pause it, look at them, and then check your answers. Okay? All right. Here is problem 2. If you need it, problem 2. In a second, I'm going to go on to the next problem. But here's problem 2. So pause it if you need this. All right. So here is the work for number 3. Okay? I'm going to stop this in about 5 or 6 seconds, so pause it now if you need it. All right? And by the way, I will say this before I stop it actually. This, if you have your calculator, I don't know that you'd have to do that on the test, but that's all under the stat button. And then stat, if you do stat edit, you can type all this data in. And then if you do stat and then calculate and then one variable stats, okay, then you can find the mean. It looks like this. And then the standard deviation is S mu. That's the, and I talked about that above, or in the other video, but there you go. Okay? All right, I'm going to stop it now. All right, so here is the final slide. So just if you want to get that, then you can. I'm going to stop the video in just a second. Of course, you can rewind or whatever you need. And definitely you can ask me questions when we come to class in the next day. All right. Have a good one.